Good morning. Welcome. As always, get rid of the timer. And here we are. Stream is live. So welcome back. It's this Thursday morning again for me. Believe it or not, until yesterday evening, I had absolutely no idea what to do today. And I was about to cancel the stream thinking, well, what's the point of just being here? I mean, you could just stream and you could look at me wondering what to do, but that would not be super interesting. But then I thought it's probably best to, well, keep on doing this. And if I think if I skip it once, I'm gonna skip it twice, and then sooner or later, I'm not gonna do this at all anymore. So yesterday evening, I then went out with the dog, took a walk, and while walking the dog, some ideas formed in my mind. And I thought, well, that could be something that I could stream about. So let me explain what these thoughts were, and then it's up to everybody to decide whether this is something that you find interesting or not. But I think it's a, what do you call it, a real world example. So something that could really be useful, that involves a lot of different technologies. And yeah, so let me explain. Right. So where do I start? Well, actually, let's start there. In 2014, I think 2014, we did some investments in our home, and it's pretty old house, so a lot of things had to be done. And so one of the things that we did is we renovated the central heating boiler, the central heating unit. So originally it's a house from the 60s, 1960s. Originally this was all heated with oil, and well, that does not quite work for me. So oil is bad for the environment, and I'm not too much into that. Also, the oil prices went up. I wanted a cleaner type of energy, so I looked at what are my options, and I figured out that, well, the area that I'm living, what we have here is really a lot of wood. I did some checks and I found that, well, using what is called wood pellets, that would be something that is sustainable, that is carbon neutral. So we decided to upgrade our home to use a wood pellet central heating unit. If you wonder what this is what these things looks like. It's compressed wood sticks that are then burned, and most of these are created from what are the leftovers when people are working with wood. So if you cut some wood, all the dust that is falling down, that's what they are made from. So that's pretty good. And if you buy them locally and not from Brazil, and I know people are importing these from pretty much the other side of the planet, which is a bad idea, but if you buy them locally, this is a carbon neutral approach. Well, so we upgraded that, and this was a pretty new technology back then, and it works pretty well. It's still in place. And the only problem is that the supplies, they don't quite last as long as I wanted them to last. So that was a mistake on the planning side. How much of these would we use? And we use about, well, 5 tons per year of these wood pellets. Sounds a lot, but that's just what it is. So the problem is we can only store about 3.8 tons. And so that means around September, October, I'm starting to get nervous, and I'm constantly running down to the basement and I'm checking this central heating unit, which I can probably show you what it looks like. What is it called? Something 15. Yeah, so I think that's it. So that's the thing here. This is the device where they where this is turned into heat. This is where they burn the pellets. And this thing has got a screen where you can check, let me see if I find something, where you can check how much, there it is. So this is what the screen looks like. It's running Linux on this device. So there you can check what is still left in the storage and what is the current temperature. You can get a lot of status, which is great. But unfortunately, if you are running out of supplies, you would find yourself constantly running down to the basement checking, well, how much is still left and do I have to order new ones? And so I got tired of that, and that's why I started to look a bit at this device, and I thought, well, if this is running an operating system, and if they can remotely access it to service it, I should be able to access it too, right? And indeed, this is possible. So back then, that was, I don't know, when did I change this? I see here, 2015 is this repository. So back in 2015, I created an application that was, or that is a Xamarin iOS and Android app that would allow me to connect to this central heating unit and daily track how much supplies is still left down there. And this is done by using it's running a server on this device down there. And so you see here are the helper methods. I created some interfaces where you can get the API version. This is all XML based. And here's the important one: get supplies XML async. So this is code from 2015. It's still working in this Xamarin application. And this is something that I thought could maybe be reused. Okay. So that's getting back to what I wanted to say. This is code that already exists. This is something that helps me automate a process that would otherwise be pretty manual and just, well, tedious to some extent. Okay, so then things went on. We had this central heating unit, and I was able to check what are the supplies. And then 2 years later, we had the idea of, well, what about making our own electricity here? Why are we paying so much for electricity if we can produce our own? Everybody should do that. So next investment was in 2017 in getting a solar installation on the roof. And we decided to go with a converter by SolarEdge, which you see here. And yeah, again, they have got a pretty nice UI that you can fire up here in the browser. They also have got an iOS application and an Android application where you can see what is going on with the energy generation. So here you can see this per month, per day, and it tells us here that this is what we're using, the red area, then green is what we are producing, and blue is what is covered by the energy that we are producing. Right. So you see, there's one more thing that I'm interested in that I want to track, because, well, if we are producing a lot of energy, then I very likely will want to, I don't know, power on the washing machine, or I want to power on the dishwasher. But that is one more piece of information that I would need on a, well, more or less daily or even hourly basis. And again, I found that they expose an API. You have to enable this in the portal, and then they tell you what are the rules to use this API. And I haven't really tried this, but I saw it's there. So I thought I already have two sources now that I somehow want to visualize. And so the idea came up that why don't I have some sort of dashboard? That's what I really want. I want to see at one glance what is going on. What is how many of the supplies, how many wood pellets are still left in the basement for the central heating unit, and what's going on energy-wise from the roof. And while I thought about this, all of this evolved while walking the dog, like I said, I found that there are other things that I would be interested in. Information that I would need on a daily or even more frequent basis. So the next thing that I then thought was, well, related to energy, what about the car? So we've got an electric vehicle, and again, it turns out that this car has got an API, and it wasn't hard to find information. And again, I already built something in the past just because I was curious. So here is a piece of code that would allow me to log in to, well, essentially my car, give them, I know the username and the password, and I can figure out pretty much everything about that car. I can even remotely start it if I wanted to do that. And So this is already there, this code is there. So what we would need is again something that calls this code here, extract the information and display it in some way. I didn't stop there. The next thing then was, well, if we're talking about things that are happening on a daily basis, I'm going to the gym twice a week and I want to know what's going on there. I want to see what is the workout there. So if I look at how this is done, this is my daily procedure. I would go to this website here, to the box, that's crossfitrosenheim.com. I go there, I would go to WOD. And there I see this is the workout of the day. So today it's back squat week. Good. So I'm checking, yep, I'm signing up for this. But again, it would be nice if I just in the morning look at some screen or an iPad and see at one glance, well, this is the workout, this is the energy, this is this, have a dashboard. And once again, I did a presentation in the past that was for a .NET meetup that was in Amsterdam, I think, where I showed a project where I would extract the workout of the day information, store it, and have it analyzed by an artificial intelligence so that it could predict whether that's something that I'm going to like or not like. That was just more of an experiment. But the important bit here is I wrote something that would allow me to extract the workout information from that website. So this code is also there. It has to be updated a bit because the website changed, but essentially this is about screen scraping. So you see the code is there. What I want to do now is to bring it all together. So now we come to the project. Let me see if I can clear this here. And I want to show you what the actual plan is. And we're probably not getting into any code today. I'm actually sure. I think I'm going to keep this first part here rather short. I want to introduce it because I also have to think all of this a bit more through. So unlike the previous stream that I did, this one here is pretty much unplanned. So let's see if we can get all the moving parts. What's that red bubble up there? There we go. So here's the idea. We have different sources, and what should we call them? Providers, sources, well, maybe we call them sources. And these sources are, no, I forgot, yeah, okay, let's get back to this. So these sources are, one of them, let's make this a bit thinner here. One of these is the pellets, right? This is where I can figure out what is left in the storage, and this is where I have to talk to this central heating unit down in my basement. Then we have got another one that would be the car, right? Where I want to know what is the current state of charge, and then I can maybe just look at that dashboard and say, okay, I know the solar roof is delivering a lot of power, maybe I want to start charging the car. Then we have got, talking about the solar roof, yeah, we have got solar here. And then the last one, that would be, for now, the workout. This is where we would have the screen scraping. So these are, but for now, 4 different sources. And as I started to think about this project, I noticed that, well, what if there are other sources that I can't think of now? So what I wanted was something that is pretty flexible. So these are my sources, and what I expect as a result is, or what I imagine as a result is something like this here. I want to have some sort of client, and that client could either be a web page, it could just be a console app, or it could be a mobile app, preferably a Xamarin app, because that's the stuff I know. So this is some sort of front end here, and that front end is simply supposed to display information about these sources. So here it would maybe show that we've got, I don't know, 3,000 kilogram of wood pellets left inside the in the pellet storage, or that we are currently producing, I don't know, 7 kilowatt from the solar roof. And we could see that here, I'm not going to write this here, we've got some text information that would be the workout of the day. And then maybe for the car, I will want to know, maybe I want to know different things from the car. Maybe I want to know what is the state of charge, and maybe I want to know the location. So maybe I have these two things here. So that's my front end, and that front end should be something that works in the browser, that, like I said, works in the console, that works on a mobile app. So it should be pretty simple. There should not be a lot of logic in it. It should mainly be about displaying things, and it should be pluggable, configurable. So as I add sources, I want them to show up there. So this front end, I reckon this is going to be, well, this is maybe going to be ASP Net Core, or it's Xamarin, or what did we say? Console. So this should be one part of this project here, and I want to be able to completely, yeah, like I said, make this separate, make this independent of the remaining parts that we have here. So that's the front end. Then up here, we had the other thing. Those were our sources. Now, what about these sources? That's these three here on the right-hand side, the car, the solar, and the workout. These three are all accessible from anywhere. That means I could write the code and deploy it, for example, to an Azure function. And that's really what I'm thinking. So this here should be an Azure function. This should be an Azure function. And that should be an Azure function. And actually, the one for the workout, that already is an Azure function. So when I developed that first, where I passed it on to the artificial intelligence, I made that a function. So this makes kind of sense to have a function. That function then performs or uses HTTP client maybe to grab the content of the website, extract the workout information, and then return it in some JSON format. So that's what they all three have in common. They all return some JSON. That's what we get out of here. That's how I think this will work. So they're gonna generate JSON. Now, this JSON format is, it needs to be a specific format, but I think we'll get to that. Let's first talk about the leftmost one, the pellets here. So why is this one different? Pellets is different because here with this one, the issue is that this is not reachable from the internet. So this is something where, yeah, this server is running, it's running in my basement. So you cannot get there. It doesn't have an external IP, and I'm not sure if I want to expose that to the internet. That would maybe be possible by setting up a tunnel, or I don't know these things simply. So one solution would be to get this into the internet, which I don't want or can't do. And the other option is, well, I want to learn about Azure technology anyway. So maybe this is a good candidate for learning about something new. Maybe Pellets works differently. Maybe here we have got a chance to run some code internally, maybe here on my Windows PC or on the Mac, or maybe on a little Raspberry Pi or some other IoT device. And that device, let's just assume it's going to be a Raspberry Pi, because I really would like to work with these. Let's assume it's a Raspberry Pi, and that would then, I don't know, every hour or every day or so, talk to the central heating unit, read the XML data and then somehow transform that XML data into JSON and submit it to the only source of truth, which we have to discuss. So somehow this all has to be stored somewhere. And as I said that I probably want to develop this first locally here on Windows or on the Mac and then move it somewhere else, I think this could be a candidate for containerizing this. So here I could imagine that this is going to be a Docker container where we run this. So this contains some code that then again generates JSON. And then I could just take this container and run it wherever I like. I could run it in the cloud if at some point I decide to expose that central heating unit API over the internet. I could run this on my Raspberry. So that's, I think, a good solution, and it's something for me to have a reason to learn about these things. So those are our sources that we have here. Now, what about the JSON format? I thought it should be possible to add other sources here more or less dynamically. And these sources should really be either something that is reachable via a RESTful endpoint, like that's the case here for car, solar, and the workout, or it should be something where JSON is generated and then somehow provided directly. And the front end should display the returned information without needing any additional configuration. So I would just somehow say, okay, these are the sources that I want to display, and it magically knows what to do. Now, of course, there's no such thing as magic. So that's why I thought, let's make that JSON a format where it can be interpreted and the results or the information how to display something is included in that JSON. So maybe that JSON is gonna look something like this. We might have some identifier in here. I'm gonna make this even thinner, I think. That we're gonna have some ID. And just as an example, let's use let's use what the car would return maybe. So that would be some ID, that would be car. That's just a way of registering, identifying this. Then every JSON would contain a title. So this would be, well, what do we know? EV data, right? Just as an example. And then every JSON response would have an array of data. So here's our data. I'm skipping the curly braces now. I just say this is an array here. And in there we would have tuples or triplets of data. Not sure yet what is going to be in there, but that data would maybe contain a label. So that label would maybe say, in this case here for the car, state of charge, SOC, what is currently in the tank, in the battery. And then it would have a value, and that value would be, I don't know, 50 kilowatt hours, something like this. And I don't know, maybe every data entry also has got an ID. It could be that this is necessary. I'm going to call this state of charge too. It could be that we need to identify this. So that would be one entry in here, this one here. And then we could have another one in there where the label would be, what else could we know? Yeah, location. That was the other example. Where is that car at the moment? And again, it would have a value and an ID. And we could also imagine that, yeah, maybe there's a type in there that says, well, this label here, that's string, or the I don't know, the state of chart, that's a numeric value or decimal value. Or it could say that this is something that should be exposed as a graph. I don't know. We'll see as we go. So the idea is that if our front end here wants to display this JSON information, it can just read through it. It can generate information, like it can say here, it can say this has got the title EV data, because it knows this is the property that it can read from the JSON, that's the title. And then it can just iterate over what is in here and dynamically generate the entries. That's the idea behind it. So every piece of information that we have here on the front end can be dynamically generated without having to add any specific source-specific code. So that's this thing here. Now, the idea is that all of this should be configurable, it should be flexible, it should be possible to add sources without taking down all of the project. It should be possible to remove sources without destroying anything, and it should be independent on the technology that is used on the front end, or so that's the general plan. So what can we do? Well, I think we're gonna need some sort of registry. So we've got what are the different sub projects here that we will have to tackle in this stream. So number one is, or maybe not number one, just one of them is the front end. Then we've got the different sources that we'll have to look at that need to be implemented. Then we have got some sort of registry that has to be stored somewhere in the cloud, and I don't know yet what that's going to be. So right now I'm thinking Cosmos DB table storage, or in general table storage API. Sounds a bit like overkill, but then again, table storage is cheap. But maybe there's something else that we can use. But anyway, in this registry, I imagine that we're gonna have a registration of all the different sources. And this would maybe say we've got pellets here, so using these IDs that we have, and then we've got the car, and we've got the solar, and that would be in a table. That would be one entry here, one column would be the ID, and then it would have some sort of URL where to find this service, because like I said, it could be anything. I don't want to tie this to any technology where this source is living. It could be anything that returns this valid sort of JSON here. Now the pellets, like I said, is a bit special. Maybe, so this has got another HTTPS. So these two I know for sure, they are RESTful endpoints. Now pellets, I don't know yet. We'll have to think about that, because this is nothing that can be retrieved directly. And then we have, we've got some sort of refresh timeout, I think. So we could say here that, I don't know, the car should be updated every 1 hour. And the storage, the pellets, that should be updated every day, once a day. And then it would have one last column that's something like last update. Running out of space here. Last update. So it would know when did it last call this endpoint to retrieve data. I'm still hoping this is making sense. We'll see. I think it does. That means I need some piece of code running somewhere that regularly checks the registry, goes over the entries in the registry, and sees if it's time to refresh one of the sources. and I could dynamically add entries to that registry. And the next time my aggregator, whatever I want to call it, runs, it would pick that change up and query that source. Now, having this background of Azure and Microsoft, I think that most of what is left to do now is going to be Azure Functions. So that's the registry, and then we have got 4. We've got all of our logic somewhere. So this is now where we want to bring everything together. So for this code that regularly is going to check the registry, let's just assume this is running. How often would this run? Once a minute, once every 10 minutes, or maybe just once an hour. So this is something where I don't want to pay for a lot of resources, because most of the time it's not doing anything. So this is also one of the main ideas behind this. I want to make this as cheap as possible. So if we think about the goals, it should be, what do we have? It should be flexible. It should be cheap. I don't want to pay for hosting. It should be fast, I think. That's also a requirement. So if I want to know what is the current status, I want to be able to see it immediately. I don't want to wait a long time. And it should be independent from technology independent. As we talk about the sources, technology independent. So these are the kind of the requirements that I have here. Now coming back to our logic and trying to meet these requirements, we need something that checks every X minutes or seconds. So I think we're gonna have a function that is time triggered, function that has got a timer, and that function is going to access the registry, and it then talks to the endpoints, or in the case of the pellets, yeah, like I said, I don't know. I think we got to find another way of letting it provide data. But let's talk about the ones that have actual RESTful endpoints. So here we've got a timer, and I want that to be able to reach out to all of the endpoints at once, if possible. Now the thing with functions is that the functions 2.0, they are meant to be stateless, and they have an execution time limit. But recently I learned about something new, which is called durable functions. And durable functions are technology on Azure that we can use to chain other functions together to add some sort of state to the otherwise stateless functions. We can use it to fan out, like execute a bunch of functions, and then also fan in again, get the results from all of them, and then do something with it. And it sounds a lot like this is exactly what I want. So this is going to be a timer durable function. And that, let's say, that runs every minute. So I only pay for the time that it is running, which meets my goal of making this cheap. That would then read the registry. It would then execute. And execute means communicate with these endpoints that are registered in the registry, which are either other functions or any other source that I can imagine. But we could think about yeah, maybe somebody who's watching here decides, well, I'm going to create a source for, I'm going to create a source where you can pick up the current weather and expose it in that JSON format that we define here. So you could just register that endpoint there and it would pick that up too. So that's the idea of this timer function there. And executing would mean, in the context of durable functions, that would probably be an activity trigger, but too many details here. So there would be another function. Can I please zoom out here again? Thank you. There would be another function which is called by this one here. So this is what I mean by execute. That's just an implementation detail really of durable functions. So this is what calls the other endpoints. It would execute a provider or a source. Execute one individual source now. So the timer durable function is acting on all of them, and this is executing one, and it would store the results. So let's assume it's calling the endpoint for the car. It gets back this piece of JSON that says, well, this is the current information that I have. And maybe our JSON here should maybe contain a timestamp, right? That could be useful. Just do ... here, so that we know when was this JSON generated. It would store the results and it would put them into some sort of database. So very likely, I said this is going to be a some sort of database where we store the history. Very likely it's going to be in a Cosmos DB with table APIs, because it's fast and cheap. So here we've got our history. So it's going to store it in there. So we would have a history in here that would maybe say, well, there's one entry from the car, there's another entry from the car, there's one entry from Solar, and there's one entry from workouts. So that not only will I be able to retrieve the current value on my dashboard, but I would also be able to select one of the panels on the dashboard and see, well, what are the historic values? And maybe we can think about extending this in the future. We could think about, well, let's use, for example, the information returned by the pellets endpoint to predict how long the supplies will still last. So I could compare year over year and maybe extrapolate and see, well, this is when you should buy new. So there's lots of possibilities in there. I wonder why this whiteboard is so slow here. So that's our logic. So the question is now, once we have all of this in the database, how do we get it onto our front end? And I want to avoid to couple things, to tie them together and make them depend too much on each other. So it maybe seems a bit like overkill, but this is also, it's for me, it's a coding practice, and it's some sort of practice to plan how to build such a project. So what I currently would like to do is, and I have to investigate that a bit, the front end part. Let's assume that this is going to be a web page. Coming back to it should be cheap and fast. I don't quite want that to be an ASP.NET Core website. Like it's not changing too often. And to do this, I would have to create, I would have to run a web app service, which I have to pay for, even if nobody's looking at that website. I could, of course, containerize that, and I would have to pay for the container, and I'm not quite happy with that. So what I think instead is maybe this should be static. Maybe we should have something where whenever new history values arrive, something triggers the recreation of a static page or static site, which we can then put into Azure storage. And so if you go to the browser and look at it, you just get plain vanilla HTML. But on the other hand, we still want our mobile clients, for example, or a console app to be able to retrieve information. Now, this would be more dynamic. So what I think we need here, down there, I wonder, can I move this up? Can move this up here. What we need down here is another, well, logic on the logic aggregation. Maybe I'm going to call this here. Maybe we would need something else down here where that would be 5, right? Where we would have logic access. And so we can use bindings with Azure or with Azure Functions so that whenever we write something in here in our history database, we could probably make it so that it's going to regenerate or run some code that generates that static front end. I don't know yet what technology to use there. I'm gonna do a bit of research. But the other thing that I will certainly need is another function in here, which has got an HTTP trigger, where you can simply issue a GET and say, give me the latest data points for all of our sources. So that would be get sources data. So I would call that and it would tell me, well, this is the current value for the car, this is the current value for the solar, this is the current value for this and that. And it would always retrieve them from the database, and we could maybe say include history, right? But that would be an enhancement. So that means if I have got a mobile client or another dynamic client, it would be able to directly get that. And of course, I mean, I'm dreaming. So we could add more logic, like I can think of SignalR service, right? Why not? SignalR service. So we could say that we want to push updates, push source changes. Now this could mean whenever a new entry is added to the history database, maybe we aren't even recreating the website. I don't know yet. Maybe we are just, or maybe we are recreating the website, but assuming that somebody is currently looking at that website, maybe we want to give them a live update. They could say whenever something is pushed, the website could register with the SignalR service. It could be informed and dynamically update that particular panel that was changed. So that would be something to add. And now, like I said, the only unknown is, what about endpoints that are not reachable via URL, like my pellets here, which is a good example. Now let's assume this is running locally maybe there's some service running here on the PC or on that Raspberry. It's reading the XML, it's parsing the XML, it's turning it into JSON. It has to have a way to upload that. So it, yeah, I think why not? Why don't we have a function which is an HTTP post, where you can store source data. Oops. It's almost unusable, this whiteboard. Store source. So what I mean by this is the Raspberry service would run locally. It would call this endpoint, and then that function endpoint would write, it would write into, yeah, probably into the database, right? So this would somehow call this puppy here. And I think like that, I could connect everything. So the next time the aggregation function, this one here, runs, it would see, well, yeah, what I have to look for are these three in here: pellets, car, solar, no matter where they come from. I understand that for pellets, I don't really have to call anything. So maybe this would be a null entry here, or a special magic string that indicates that this is nothing to call, but just to skip. It would update the value for it would just set the timestamp in the registry, but not really do anything. And we would always have the latest values in that history DB, no matter where they come from. Something like this. And I think with that, I would get my dashboard. Then, of course, the next step would be to discuss with my wife whether it's okay to buy another iPad that will be installed in the kitchen, that is constantly on, and the only thing it ever displays is this dashboard. But I remember there was a project by, was it Scott Hanselman? Let's have a look at this. This is also what this is inspired from. He did this, he had some display. Was that with Raspberry LCD? There, wall-mounted family calendar. Let's have a look at this. Right. This is kind of what I imagine. A Wi-Fi connected wall display. So what did he use? So he got a Raspberry and 24-inch old LCD. That's good. I don't need no calendars. So the question is, how do you connect this? Oh, you're just gonna, yeah, that's cool. So maybe that's really it. So maybe we wanna, maybe I want to set up like that, really. Have a Raspberry, have some cheap LCD that is connected to the Pi. I see, this project is getting bigger than I expected. So let's keep this for later. Let's keep the Pi story for later. But I think this is the plan. And like I said, probably no code today because I don't really know where to start. I have to think this through. Very likely that in the next session we're gonna create the functions project, or just create the initial project. It's already there on GitHub, so it's github.com/grumiller/dashboard. put this on the chat window. Feel free to contribute there, add your ideas if you're interested. And then, yeah, set up the functions project, or set up the project in general. Add maybe what I have here, this whiteboard content. Turn this into something PowerPointy and put it there. Have this information there. Maybe create some issues and plan a bit out where to start. Maybe one of the first things you want to look at is how to get these sources work again, because most of the code is there. It's just that, well, part of it was written in 2014, 15, so we're probably going to port that over to .NET Core. The screen scraper for the workout, that has to be updated, and maybe just start creating, yeah, either simple console test projects so you can see if all of this is working, or maybe create some unit test project. I know it's not a unit test, but that will probably be the first steps. And then have a look at Azure. What are the technologies that we're going to use? So currently my favorite is, I think Azure Functions is set. That's what we're going to use. Table storage, yeah, I can't think of anything else. If you have got another idea what to use instead, let me know. But I think that would work, gives us the flexibility and the low price that we need. And then what I want to save for last is the front end, because this is what I fear most, because I have really no idea about JavaScript. Maybe this is a good reason to learn about these things. I think there's templates for one-page applications, right? For one-page websites, which are all driven by JavaScript. Maybe it's not too hard. Maybe you can just copy something somewhere and change that a bit and reuse it. And then, of course, the client app. Maybe using Xamarin Shell, I don't know. Xamarin Forms 4 was just released to stable. I haven't tried Xamarin Forms Shell either. So lots of things to investigate and to look at. So I'd say with that, I'm gonna call it a day. This all makes sense to me. I hope it makes sense to you. I hope you found that interesting. And I'm looking forward to seeing you again next week when we get our hands dirty and start working on the code, on the actual implementation. Until then, thanks everybody for watching, and see you next week. Bye.